Okay, we are back and I'm going to talk about chapter 6 again. We haven't finished it yet. See how much of it we can finish. Most probably 6.4 and 5. So we are going to talk about graphs of logarithmic functions and logarithmic properties. At least that much we probably going to be able to do. Okay, I hope you're doing well. I'm going to start by looking at some problems in this section 6.4. So what we are going to do is talk about maybe starting with number 6 here. So we talked about graphing. So let's talk about logarithmic functions and their graphs. So let's say we have, let's review quickly right here. We know that if we have a function that is log base b of x, and x is, b is greater than 1, it would look like this. It goes through 1 and goes to infinity this way, but then it goes to negative infinity this way, right? Kind of that shape. And this is 1. That's what it looks like. Now, if you have logarithm with base b, but b is between 0 and 1, then the graph looks like a decreasing graph like that. And it still goes through 1 because that's where the domain is. The x is 1, the y is 0. Now, the domain of regular logarithm with the argument of x is obviously from 0 to infinity. And the range is all real numbers. Now, what if the argument is not x? Let's say we have log base 10, which we don't write, and let's say it's x minus 1, right? What's the domain of this function? Well, the domain of this function is whatever that makes the argument greater than 0. Remember, the argument of a log cannot be negative and cannot be 0. Because remember that the argument of log is the output of what? Of the exponential. And exponential, of course, is always positive, greater than 0. All right, so x minus 1 has to be greater than 0. That means x has to be greater than 1. So the domain of this is 1 to infinity, and 1 is not included. All right? And also, we can graph logarithm using these two parent functions, right? So let's just start. Number 6. We want to graph this and state the domain and range of the function. So we're going to start with the graph of log base 3 of x. So what does log base 3 of x look like? Well, let's call this function g of x, and then this f of x is the one we want to graph actually, right? Which is f of x is log base 3 of x plus 4, right? So what are we doing to this graph to get this graph? Well, remember, adding 4 to x in the equation will do what? We'll move the graph to the left, what? 4 units. So this graph, because this is 3, so this graph will look like this. Right? So this point is 1, 0, right? Now we can have another point on the graph A point that has a round answer, for example, 3. What's log base 3 of 3? Is 1, right? So we can go to 1, 2, 3, right? And say this y value here is 1, right? So we got 2 points, 3, 1, and then 1, 0. Now we know that the vertical asymptote for this graph is what? Is x equals to 0. Now we can graph this. First of all, where does the vertical asymptote go with this transformation? Remember, a point on this graph will be transformed to what? Now, x would be x minus 4, a minus 4, and the y doesn't change because there is no change in the y here, right? Just x. When you add 4 here with the points, you actually subtract 4. Alright, so where does the x equal to 0 go? Well, x equal to 0 has to be x 0 minus 4. So it goes to x equal to negative 4. So x equal to negative 4 is over here. So that would be the vertical asymptote of this graph. And then 1, 0 goes to what? Goes to where? It goes to what? It goes to negative. Now what is 1 minus 4 is negative 3, right? And the 0 doesn't change. So it goes to negative 3, 0. And what about 3, 1? Where does that go? Well, 3, 1 is going to go to, we have to subtract 4 from x value. So 3 minus 4 is negative 1. The 1 doesn't change. So negative 1, 1, whoops, the wrong place, is right here. So let me erase that little point I put there. Alright, so 1, negative 1, and then 1, right there. So the graph is going to go this way, right? And then it's going to go this way and go through the y-axis, and we get that. Now, what's the y-intercept of this? Well, y-intercept requires solving logarithmic equations when we get to in the next section or a section after that. But we can do it here. So what do we want here? We want x to be what? X to be 0 and see what y is. We don't even have to solve that much equation. You just have to substitute 0 for x, right? So if we put the 0 for x, we get log base 3 of 0 plus 4, which is just log base 3 of 4, which we don't know what it is, and we're going to get to that in the next section. It's some number. Now we know that we want a number that if you raise 3 to it, you get 4. Obviously that number is not 1 because 3 to 1 is 3, and is not 2 because 3 to 2 is 9. So the number we want is some number between what? Between 1 and 2, so it's 1 point something, which basically this is 1, so that's 1 point something, right? We're going to get to how to find this with the calculator in the next section, but for now that's what it is. So now we can see the domain. Of course we could have found the domain differently, but right here from the graph we can see the domain is from negative 4 to infinity, and the range is all real numbers, because for the range logarithm has no restriction, it's all real numbers. Now can we find the domain without actually graphing? Yes. The domain would be x plus 4 has to be greater than 0, so x is greater than negative 4, right? All right, so let's do number 7 as well. So we're not going to graph it, we're going to just what? Just find the domain. So h of x is ln 1/2 minus x. So we want 1/2 minus x to be greater than 0. So that means we move the x to the other side. X has to be less than 1/2. So negative infinity to 1/2 is good, right? Any number from negative infinity to 1/2, that's the domain of that function, right? Again, graphing it, we're going to get to graphing this more, but for now we just want to find the domain, and we did. And the range of this function would be all real numbers. The range is all real numbers. Now, let's see if we have room to actually graph it as well. Okay, so let's graph it. So what is ln x? Let's call this f of x. So ln x, we know how to graph it. Again, ln has a base of e, so it's greater than 1. So it's going to look like one of these increasing ones, right? And this point is going to be 1, right? Now, what's the transformation? Well, to get the transformation, let's say we have a point a and f of a on the original graph. Where does it go? Well, let's see. F of a doesn't go anywhere because there is no y transformation here. It's all about x. And remember, this is tricky to get. So what we do is we take a and set it equal to 1/2 minus x. So if there is more than one operation happening to x, we're going to do it this way so we know what happens to the points. So now we move the basically x to this side. We can move the x to this side, move the a to the other side. So it would be 1/2 minus, right? So you have to get x multiplied by negative, and then you have to add 1/2 to it. You can write it this way to see it. So the negative a first, and then 1/2, right? If you follow order of operations here, it would be negative. First you start with a multiplied by negative, and then add 1/2 to it. So that means we have to take a minus 1a minus a, and then plus 1/2. That's how we change the x. Now, we know that this vertical asymptote is x equal to 0, right? So what happens to it? We have to multiply 0 by, you have to multiply 0 by negative 0, negative 0, 0, plus 1/2. So it goes to 1/2. X equals to 1/2, right? So that's where this x equal to 0 is going to go. Now we can graph it using, what about this 1, 0? Where does that go? Well, 1, 0 is going to go to where? So let's graph it here. So 1, 0 is going to go to, according to what we have here, is negative times 1 is negative 1. Negative 1 plus 1/2 is negative 1/2, right? So it's 1, you put it here, negative 1 plus 1/2 is negative 1 plus 1/2, which is negative 1/2. The y doesn't go anywhere, so it's negative 1/2, 0. So let's say if this is negative 1, negative 1/2, 0 is over here. That's where that point goes, right? And then our vertical asymptote is going to go again to what? 1/2. So vertical asymptote is going to go, oops. Okay, there you go. So why is not graphing? Okay, so that's vertical asymptote. Now we have to get another point on this. So why don't we, E is like 2.7 something, right? So we're going to put E here. We know ln E is going to be what? Is going to be 1. right? So E goes to 1. And you know E is 2.7 something, right? So where does that point go to? Well, if you put E here, it would be negative E plus 1/2 is like 0.5, right? So if you assume that this is 2.71 plus 0.5, what do we get? We get negative 2.21, right? So this E and 1 go to negative 2.21 and 1. So negative 2.21, that's negative 2, it's negative 3. So it's about here and then 1, right? Oops. That's 1 right there, okay? So what is the y-intercept of this? The y-intercept of this would be, if x is 0, would be ln 1/2. And we don't know what ln 1/2 is, but basically is e to what power is 1/2, right? You can use a calculator to do it, but we are going to just assume that this thing is going to go here and cross and approach that line and go this way, right? And remember that's negative 1/2 right there. Okay, and this number is, it was 1/2, right? Because this is x equal to 0, so it goes to x equal to 1/2, and y doesn't change. So you see, basically is, you can think of it as, you can think of it as reflecting it, right, over the y-axis, and then moving it to the left, right? Moving it to the, you're adding, so moving it to the right 1/2. So reflect it. If you reflect this over and then moving it to the right 1/2, that's what you're going to get, right? So that's the idea of graphing it. So now you can find the domain. Of course, we found the domain already, but I wanted to graph it. We're going to graph some more of these, but for now, that's how you graph it. All right, so let's look at some more examples of this section. What about number 10? So let's see, you don't have to graph it. No, just find the domain, right? So finding the domain of this. Well, let's see. Let's find the domain. It's very easy to find the domain. 12 minus 3x has to be 0, greater than 0. So we can get 3x here and move the 12 to the other side. And then when you divide by negative 3, you have to switch the direction here. If you divide by negative 3, you switch the direction of the inequality. So you get x here, you get negative 12 over negative 3. So x is less than 4. So that means all numbers from negative infinity to 4 will work, right? Again, if you were to transform this graph, this is log base what? This is log base 2 of x, right? Let's say this is, you can call it, let's call it, since this is f of x, we call this g of x. So log base 2 of x. So what are the transformations that are happening here? Well, the transformations that are happening, let's see. The y, so if you have a point here, a and g of a, we know the y is just what? Subtract 3 from it. That's it. So g of a minus 3. That's all. What about the x? What's going on with the x? Well, we have to set this equal to a and solve for x. So to solve for x, we can move the 3x to this side and move the a to the left side. And now we can divide what? divide by 3. So that's what happens to x. We get 12 minus a, and then divided by 3. Now, we don't want to write it like that. We want to exactly know what's going on. So what we have to do is, we have to think of 12 minus a over 3 as 12 over 3 minus a over 3, which is basically negative a over 3 plus 4, because 12 over 3 is 4. And negative a over 3 means negative 1 over 3 a plus 4, right? Now we know exactly what happens to our x coordinates, right? So let's write the different different transformations that we get by this function right here, right? That's the function. So the transformations are in the direction of x and y. That means with respect to changing y or changing x, what are we doing to them? Well, the y, we just subtract the 3, so it's a shift down by a factor of 3, right? Down 3. What about in x? Well, in x, we have to follow the order of operation here. So we multiply by 1/3. That means is what is a horizontal. If you divide by 3 or multiply by 1/3 on the points, then you get horizontal shrink. So it's a horizontal shrink, right, by a factor of 1/3. Then you multiply by negative, so that's a reflection, right? So remember, if you make x negative, it's a reflection over y. So reflection over y. So that's one. That's another transformation. And then you add 4. If you add 4 to the points, you move it to the right, right? So to the right by a factor of 4, right? So again, let me rewrite here what happened. So in the x, we're going to do horizontal shrink by a factor of 1/3. Then we're going to do what? We're going to do reflection over y. And then we're going to do shift right, horizontal shift right by 4, right? In the y direction, we're just going what? We're just going down 3, right? Now you can do this in any order, but you know, these have to be done in this order, and that's only one, so you could just do it. So the way you graph this function is by putting some points here. So that point, of course, we know is 1, 0, right? And is log base 2, so you can put another point, maybe 4 here. So 4 goes to what? Goes to 2, right? So 4, 2. So you can get these 2 points and graph this function by hand, right? And see what happens to these points, right? And you can graph it. So what happens to 1, 0 under this transformation? Well, if you put 1 in here, negative 1/3 plus 4, right? What's negative 1/3 times 1 plus 4? So that would be negative 1/3 plus 4. Now 4 with the denominator of 3 is 12 over 3. So that's 12 over 3, and then plus negative 1/3. So that would be 11 over 3, right? So it goes to 11 over 3. And the y coordinate, you just subtract 3 from it. So it would be negative 3. Because 0 minus 3 is negative 3. So that's where that point goes. And the other point goes to 4, 2 goes to what? Well, again, negative 3, negative 1/3, right? So let me erase this. So negative 1/3 times 4 plus 4. So that would be negative 4/3. That would be negative 4/3, again, plus what? Plus 12 over 3. And that's what? That's 8 over 3, right? So that's 8 over 3. And then 2 goes to where? Well, 2 minus 3 is negative 1, right? So if you graph these 2 points, we also know where does x equal to 0 go, which is the vertical asymptote. Well, x equal to 0, again, we have to put what? Let me erase this. So we can put negative 1/3 times 0 plus 4. So that's just 4. So x equal to 0 goes to what? X equals to 4. Now if you graph all this, you get graph of that right there, right? Okay, so that's how you graph these things. All right, so we got number, let's do a few more of these. So state the domain and vertical asymptote for this. Again, let's do that. We just want the domain and want to know where the vertical asymptote goes, right? So domain of this would be x minus 5 has to be greater than 0. So x has to be greater than 5. So domain of this thing would be from 5 to infinity. Now, where does the vertical asymptote go? Again, this is log base 10. So it's looking like this. And the vertical asymptote is x equals to 0. So this transformation is what? Moving to the right 5, so you have to add 5 to x. So x equals to 5 would be the vertical asymptote, right? And then you can move this 1, 0, see where it goes. And you can take another point if you want, and you can graph it. But we were told to just find the vertical asymptote and what? And the domain. Okay. Now in number 12, the same thing. So what's the domain? Well, if you move the x to this side, it will look like this. So x less than, so it would be x less than 3. So that means anything to the left of 3 is the domain, right? And then where is the vertical asymptote for this? Well, what transformation is this? Let's see. So 3 minus x, right, equals to a, right? Remember how we figure out what happens? So we think of f of x be the original ln x, which looks like, again, looks like this. The vertical asymptote is x equal to 0 is this line right there. And this point is 1, 0. I mean x equal to 0. Didn't get it. Okay. So where does it go? Well, let's see. We solve for x here, and we find out what happens to a, right? So x equals to that. So that means if we have a point on the function, the parent function, where does it go? Well, it goes to 3 minus a. Well, 3 minus a, we can write it as negative a plus 3, right? That's the same thing. So negative a plus 3. And then the y doesn't change, because this is only transformations in horizontal transformations. So so this is negative a plus 3. So where does x equal to 0 go? Negative 0 plus 3. So it goes to x equals to 3. That's the vertical asymptote, and the domain is this right there. Okay, so let's see. Let's do number. Here it says, for the following, you state the domain, vertical asymptote, and end behavior of the function. Well, let's look at it, and we can actually graph it as well. So again, the domain of this function would be x is going to be less than 2. So it's from negative infinity to 2. That's the domain, right? Now, what about vertical asymptote? Well, again, we have to look at ln x and see what happens to it, right? So let's call this g of x. And let's say we have a point A and g of A on that graph. Where does it go? Well, the transformation again is 2 minus x. So we let A be 2 minus x. So we'll move the x to this side, move the a to this side. So x equals to 2 minus a. Again, we're going to write it with order of operation like this. So we know exactly what to do. So the domain is that, and now where does, let's graph ln x again. Ln x looks like this, and it goes through 1, 0, and the vertical asymptote is x equal to 0. So x equal to 0 goes to 2, right? So you see vertical asymptote here is at 2 if you look at the graph here. So vertical asymptote is at 2, right? That's vertical asymptote. Negative 0 plus 2 is 2. And then where does 1, 0 go? 1, 0 go to what? 0 doesn't change, but the 1 part of it is going to be negative 1 plus 2, which is 1, right? So it stays at 1, 0, which is right there, right? All right, now we need another point to figure out what's going on here. So let's get ln of, so this is the original one. So we're going to get ln of 1, right? So ln of 1 is 0. What is ln of, let's say ln of some number that can give us, so let's say ln of, this is 1. So let's see. Let's say ln of e. E is good. So let's say e again. Now ln of e is going to be 0. I mean ln of e is going to be 1, right? So we gotta, I have to make this a little bit lower so it makes sense to what I'm doing. Here we go. I'm gonna get a little bit lower. So ln of e is 1 here. So it would be e and 1, right? So where does e and 1 go? Well, e, we're going to put it in here again. It would be negative e plus 2. Remember, e was like negative 2 point, that's negative 2.71 approximately, plus 2 would be negative 0.71, right? So it goes to negative 0.71. This point is going to go to negative 0.71, and the 1 doesn't change. So negative 0.71 is about right here somewhere, right? And 1. So it goes there somewhere, right there. And now we know that this graph, of course, is going to be graphed this way. We knew that because that's a reflection right there, right? Negative that's a reflection over the y-axis, and then move up, move to the right 2, right? So then you can graph it. Once you have 2 points on the graph and you have the vertical asymptote, you can graph it, right? All right, so that's that. Let's see. Let's do again number 18. So another problem. So what's the transformation here? Well, again, we're going to look at f of x equals to, this time, just log base 10 of x, which doesn't really matter. It still looks like one of these, right? So it goes through one and goes through, let's say, 10. If x is 10, log base 10 of 10 is 1. So let's say this is 10, so it would be 10 and 1, right? The vertical asymptote is still at x equal to 0. Now, if we have a point here on this graph, on the original parent function, what happens to it? Well, let's go here. The y would be multiplied by negative and then added 3. Remember, remember when we did transformations, we assume this is the right hand side. So what happens to it? You multiply by negative and add 3. So multiply by negative and add 3. Now what happens with the y, the x? Well, for the x we have to do this. 3x minus 4 equals to a. So 3x equals to a plus 4. So x equals to this divided by 3, or multiply by what? By 1/3, right? So we can write it this way, right? So we can add 4 and then multiply by 1/3, right? So we could just write it as 1/3 times a plus 4. So what are the transformations, right? What are the transformations? Well, 1, 0 is going to go to what? Well, 1 plus 4 is 5. 5 times 1/3 is 5/3. And then 0, negative 0 plus 3 is 3. So that goes to 5/3, which is what? Is 1 and 2/3, and what? And 3. So 1 and 2/3 and 3, somewhere over here, right? That's a 3 right there, right? And then where does 10 and 1 go? Hopefully it's going to stay in this window so we can graph it. So where does it go? Well, the 10 goes to 10 plus 4, 14 over 3. 14 over 3 is like 4 and 2/3. And then where does 1 go? 1 goes to negative 1 plus 3, which is 2. So 14 over 3 is 4 and 2/3 and 2. 4 and 2/3, about right here, and 2. So that's where it goes, right? Now, if you think of transformations, we know the vertical asymptote goes where? Well, x equal to 0 goes where? X equal to 0 goes to, again, we have 1/3, 0 plus 4 is 4. 4 times 1/3 is 4/3. So x equal to 0 is going to go to x equals to 4/3, which is 1 and 1/3. And 1 and 1/3 is about right here somewhere. Right? A little bit more than 1. 1 and 1/3. So this graph is going to go approach its vertical asymptote and come down and go to infinity. Eventually it's going to cross. Eventually it's going to go that way and cover all the y values here. So eventually we'll go and cross the x-axis, but very slowly. And you can find the, again, when we do the equations, we can find these values. But for now, that's good enough for us. All right, and notice that this doesn't cross the y-axis, because if you set 0 here, then the domain is going to be -4. Log of -4 is not defined, so that means it doesn't go through y-axis, right? All right. So again, we graph with computers and calculators. The point is to understand how these points actually are transformed, right? And what they do to the behavior of the function. So the end behavior of this would be when x goes to infinity, gradually the y is going to go to what? -infinity, gradually. And then on the left, of course, the domain stops it at, the domain of this function is, did we find the domain? Domain is that 3x minus 4 has to be greater than what? 0. So that means 3x is greater than 4, so x is greater than 4/3. So domain would be from 4/3 all the way to infinity, right? And you see it here, from 4/3 to infinity. All right. So let's see what else we can do here. So state the domain, range, and x and y intercept if they exist. If they don't exist, write do not exist. Okay, so let's do that. So we want the, again, what did we want? We want the domain, range, and x and y intercept. Okay, so the domain would be x minus 1 greater than 0, so x has to be greater than 1. So domain is from 1 to infinity, right? Now, x-intercept is when y equals to 0, and the y-intercept is when x equals to 0. Now this one we can easily find. Just substitute what? Log base 4 of, right? We have to put 0 for, what does that mean? Well, log base 4 of -1 doesn't make sense. So this doesn't make sense. So that means there is no y-intercept, none. Now what about x-intercept? Now to find the x-intercept, we need to put log, well, let's do somewhere we have room for it. So let's see, move that side a little bit. So let's do it over here. So to find the x-intercept, we have to put log base 4 of x minus 1 plus 1 equal to what? 0. Now to solve this equation, which is going to be a whole section, we're going to talk about it, but for now, just isolate log base 4. So log base 4 of x minus 1 equals to -1. We isolate it, right? Now remember how we get rid of logarithm? We do base to left side and base to left side, right? So on the left, what do we get? Well, remember these get canceled, so we just get x minus 1 equals to 4 to -1. Now we know 4 to -1 is nothing but what? But 1/4, right? So x equals to what? 1/4 plus 1, which is 1 and 1/4, which is 5/4, right? So that is the x-intercept. The y-intercept does not exist. And the domain is what? Is right here. Okay? And let me erase that. But that was a +1 there. All right. So do here. Right, so let's do a few more of these. Do 20. What's 26? Well, this is similar to what we did with exponential functions, right? Remember we said that. So think about this. Let me just talk about this, how you can tell which one is which. So remember that these are inverses. So if this is y equals to x, so if we have a function that is sharp, goes up sharply compared to, let's say, this one that doesn't go up sharply. This is sharper, right? This one is sharper than this one. So that's not really accurate, but we're talking about this side, right side. So the inverse of this is going to look like that, and the inverse of that is going to look like what? Is going to look like this, right? So this one will be, this one that is not as sharp here would be sharper, but the one that's really sharp right there would go to the right slowly, slower than that one. So that means this is like a big number. Let's say this is 2 to x, and this one is 3 to x, right? So this one would be log base 3 of x, and the other one would be log base 2 of x, right? Of course, they go, to the vertical asymptote, but notice that here, the bigger the base, the sharper the increase is. Here, the bigger the base, the slower this is going to go to infinity, right? You see that? So which one of these, you see all of these, which one is the biggest? Would be this one. Then the next would be this one, next would be this one, and so forth, right? So if we keep this and we look at the choices that we are given, let's see here. So let's look at the choices that we are given, which is right there. So we're given log base 10, ln, which is log base e, and log base 2, log base 3, log base 25. So we can see that this one right here is the one that is biggest. So it would be 25. That bottom one would be log base 25, right? Now d is going to be the next to 25 is 10. That's the biggest number. So d would be the log base 10. And then c would be the next biggest number, which is here, which is 5, right? Because ln has base e, which is 2.718. So it's this one. C is log base, well, not there, yeah, log base 5 of x. And then b would be the ln. And then this one would be log base 2, right? That's how we tell which one is which. Okay. And now I'm going to go to maybe one more. Let's do this one here. Again, it's the same kind of situation. So let's see if we can graph this. We graph bunch of, but now So what is the domain of this? What is the transformation? So we are talking about what again? Log base 10 of x, which looks like this, right? So we know this is 1, 0. The vertical asymptote is x equal to 0. And so let's say f of x is log 10 base 10 of x. So if x is 10, then log 10 is 1, right? So if this is 10, then this point right here would be 10 and 1, right? So let's graph it according to what? According to the transformations we have here. What are the transformations? Well, if you start with a and f of a, where does that go? Well, it's going to go to, the y is easy, you just add 4. So it's f of a plus 4. What happens with x? Well, the x we have to figure out. Let's see. 4x plus 16, we let it be a, and then solve for it. So a minus 16, and then x equals to a minus 16 divided by 4. So that means if this 4 belongs to both, so that's 1/4 a minus 4, right? Minus 4. So that's what's going on with the x coordinate. So we take a multiplied by 1/4 and subtract 4, right? All right, now to graph this, we need to figure out where. So let's call this point A and we call this B, right? So we know A has to be connected to B this way. So where is our vertical asymptote? Where does that go? So let's see. So our vertical asymptote will go to, let me write it here, so yeah, up there. So vertical asymptote will go to what? Well, look, 1/4 times 0 is 0, minus 4 is minus 4. So you go to x equals to minus 4. So that's the vertical asymptote, 1, 2, 3, 4. That's where it goes. Now, what happens with 1, 0? Well, let's see, 1 would be 1 times 1/4, which is 1/4 minus 4. What's 1/4 minus 4? Well, that's 4 with the denominator of 4 is 16 over 4, right? So that's 1 over 4 minus 16 over 4, which is negative 15 over 4, right? So it goes, the x goes to negative 15 over 4. Now what happens to the y coordinate? 0 plus 4 is just 4, right? All right, what happens to 10 and 1? Well, 10 goes to 1/4 times 10. So let me erase the scratch work with it here and redo it for. So 1/4 times 10 is basically 10 over 4 minus 4. Now 4 again is 16 over 4, so that's negative 6 over 4, right? Which is negative 3 over 2, right? Okay, so it goes to negative 3 over 2. And the y coordinate, where does it go? 1. Well, 1 goes to 1 plus 4 is 5, right? So 1 and 0 goes to negative 15 over 4, which is like negative 3 and 1/2, right? 3.5, right? Negative 3.5. Negative 3.5 is over here. And the y coordinate of it has to go to 4. 1, 2, 3, 4. So y coordinate is right there. So that's our a prime, right? Because a is here, so that's a prime. That's the image of a. And then for 10, 1, we have to go to negative 3/2 and 5. So that's 1, 2, 3, right? Negative 1/2, 3/2. So it's negative 1, 2, so it's going to be over here. Right there, that's the x coordinate. And the y coordinate is 5. So 1, 2, 3, 4, 5. Right, somewhere over there. So 1, 2, 3, 4, 5. So it's about right here somewhere. Right? That's what the other point is. So this is b prime. And remember, b and a are supposed to be connected this way. So this is going to kind of go this way. And then this is going to go that way, like that. That's the best. I mean, of course, we use computers and calculators to graph these things. But the point is to understand where these, what these transformations do to the graph, okay? All right, so let's see if we can look at another one. Well, we graphed it already, but that's what it looks like if you graph it, and we did already. All right, so I'm gonna stop here, and then looks like we're going to do another video. I don't want to make the videos too long, so I'm going to come over here and say again, bye and take care of yourself. See you in the next video.